General statistical techniques.
Since risks are associated with probability techniques, it seems natural that we use probability distribution functions to help describe the impact and probability of the various risks in the project. Figure 8.3 shows a skewed probability distribution. This is typical for project cost and schedule risks. The distribution shows the possible occurrences of cost or schedule completion for a particular task along. Figure 8.3, typical probability distribution for cost and schedule risk. The x-axis and relates them to the probability of that possibility occurring along the y-axis. The various possibilities are due to the risk associated with the task. For example, a task in a project has a most likely date. This date is plotted along the x-axis. The probability associated with this date has the highest probability of any other date and is plotted at the corresponding point on the y-axis. In a probability distribution, the most likely date will always be at the peak of the probability distribution curve. This is not necessarily the average date for the task, which in a skewed distribution can be higher or lower, earlier or later, than the most likely date. Notice that the optimistic and pessimistic dates are the earliest and latest dates on the x-axis and correspond to the lowest probability. There are many distributions that can be applied. They can be symmetrical or skewed. Figure 8.4 shows a few that might be used in risk analysis: triangular, even, normal, and skewed distributions. The triangular distribution shows that probabilities increase uniformly from the optimistic point to a certain point where the highest probability is reached and then decrease uniformly until the pessimistic point is reached. The even distribution has the characteristic that any value on the x-axis has exactly the same probability of occurring. There is no optimistic, pessimistic, average, or most likely point. The normal distribution is one that most of us have seen many times. It is a convenient distribution because calculations associated with it are simple to make and are generally close enough for most phenom. Figure 8.4, probability distributions. ENA that we need to estimate. In the normal distribution, the mean value and the most likely value are the same because the distribution is symmetrical. A special measurement, the standard deviation, relates specific ranges of values along the x-axis with the probability that the actual value will be between the high and low value. This is particularly useful in project management because it allows us to predict a range of values along with a probability that the actual value will occur when we do the project. A skewed distribution is one where the most likely value on the x-axis is different from the mean value. The skewed distribution is frequently encountered in cost estimating and schedule estimating for projects.